Okay, let's go over the fourth and fifth examples of factoring quadratic equations with leading coefficient positive 1. So for example 4, we have x to the fourth minus 7 times x cubed plus 10x squared. Now, this is a trinomial. This trinomial is not really quadratic because the highest power in this case is positive 4, so we somehow have to try to, try to make it into a quadratic expression, okay? Or into a quadratic expression that multiplies something else. Well, let's see. We have the invisible leading coefficient positive 1, the coefficient negative 7, and the coefficient positive 10. Well, each of these coefficients have the x variable going with them. So just like I said in the previous examples, when we first introduced factoring polynomial, every time when all of your coefficients have a common variable, we factor out that common variable that has the lowest exponential power. In this case, the lowest exponent is 2, so we factor out x squared. So after we factor out x squared, we have x squared on the outside, and then multiply all the leftover inside the parentheses. Well, after we factor out the x squared, let's see. So we factor out the x squared from x to the fourth. So the leftover of x to the fourth is just going to be x squared. And then we have the minus 7. After factoring out the x squared from x to the third, we got x to the first left, or just x by itself. And then, of course, after factoring out the x squared from the positive 10, we just got positive 10 by itself. Well, hey, guess what? We got something multiply a quadratic now. Okay, so this polynomial can be written as the product of x squared multiply this quadratic expression. Now, every time we factor, we want to factor out completely. We don't want to just stop in the middle of the way. So we have to ask ourselves, with this quadratic expression, is it factorable? Well, in this case, it is. Why? Well, one, because I've done it so many times before, that's why I can mentally see ahead. But for you guys, maybe you guys are not used to it yet. But, the way you try to factor this quadratic expression is the same as what we did in the previous 3 examples. So for x squared minus 7x plus 10, with the leading coefficient of positive 1 for this quadratic expression, we look at the first term, look at the third term, look at the second coefficient, negative 7. So for the first term, of course, it is the product of positive x and positive x. For the third term, positive 10, we want to come up with 2 numbers that multiply together to give us back positive 10, but also added together to give us back the second coefficient, negative 7. Well, let's see if I were to do it on the side. As usual, positive 10 can be written as, let's see, negative 5 times negative 2. But negative 5 times negative 2, if I were to add them together, hopefully I can see it there. I'm sorry for writing so small. I don't know why I say positive, but yeah. But anyway, what I mean is negative 5. If negative 5 were to add negative 2, that is the same as saying negative 5 minus 2. Hey, guess what? That's equal to negative 7. So that is the second coefficient that we are looking for in this quadratic expression. So negative 5, negative 2, they go in here. Oops, sorry. And okay, so the binomial x minus 5 multiplying the binomial x minus 2, the product of these two is the factor form of this quadratic expression. With multiplying x squared along, this whole thing is the factor form of the original expression.